Alrighty, hello everyone. Today we're going to be talking about convolutions in signal processing. In my last talk, we actually talked about echo removal, and we kind of black boxed something called a convolution. And actually, we avoided this operation most of the time. It was very expensive, we talked about. And so today we're going to unblack box it. We're going to discuss how we can actually do a convolution. But before that, what actually is and why would we use a convolution? So the idea is we're given this input signal X, and we want to put it through a filter. Let's call the filter H. The filter is just going to change X a little bit, and it's going to cause this output Y, right? So X convolved with H becomes Y. Another way we can write that is X, and then this operator is the convolution convolved with H of N, and this is what Y is. Cool. So when it comes to the formula, what does it look like? Well, we can write this in just a little bit of a different way. We can continue on here and say, the formal equation is what I'm writing down now. And so what it is as tau goes from negative infinity to infinity, because we're talking about convolutions, it's just simply going to be x of n and the second operator tau minus n, like so. We can also do the infinite integral version of this, but we chose to do this infinite sum version. Let's not get caught up here too much. This is just the formal definition. But now the question is, how would we actually do something like this? Well, let's come up with a dummy example and actually do one of these convolutions. So what we're going to do is we're going to do something called a circular convolution, which is just a little bit different. It's just going to be periodic, and we're going to have this sort of 1 over n scaling factor, which we won't go too much into why. It's more like a Fourier transform sort of detail. But in any case, say we had this x signal such that we had a 1 at 0, and then we had a 2 at 1. Maybe at 3 we have a 0, and then at 4 we have 3. Right? So how would we do something like this? We're just discussing convolutions. Well, what we would do is we would write our inputs first. So we would say our input is 0. So this is like the x-axis, right? So we're going 0, 1, 2, 3, we said. This is 2, 3. And then we're going to just convolve this with itself. So that's what we're doing now. Now we're going to say x, call it x1, and we said this was 1 at 0. And then we said at 1 it's going to be 2, and then at 2 it's going to be 0. I'm just reading off of here, right? And then 3 is going to be 3. Yeah, cool. So now we want to convolve it with itself, right? That's what we're doing. We're doing convolution, so we're just going to rewrite itself like so. Very simple. Now we're going to go through this formula. However, there's a very methodical way of doing it when it comes to this sort of by hand practice. So let's go ahead and do it, shall we? So we're going to start with our first signal, and for every one of our signal, we're going to just multiply by some other term of the next signal. However, when we do this, we're going to shift each time, which we'll take a look. And because it's a circular convolution, what we're going to do is we're going to take the wraparound and wrap it back around. And we'll see what I mean in just a second, but we have a few things that we have to remember to do while doing this computation. So here we go. 1 times first element of the second signal. 1 times 1 is 1. Then the next element. So 1 times the next element is 2. And 1 times the next element is 0. 1 times the last element is 3. Now I'll pause here. Do we have any questions so far? Because so far what we've done is we've said of the first signal, for each of these guys, we're simply going to multiply by another element of the second signal. So please feel free to stop me if we have any questions. So we're just going to continue on, and we're going to go to our next element of x1 and do the same thing. And the catch is that we do a shift before we write down the next element. So let's do 2. So 2 times 1 is 2. We're not going to write that here, though. We're going to write it here because we're doing shifting. And that's shifting is very important in convolution. So 2 times 1 is 2. 2 times 2 is 4. 2 times 0 is 0. Now here's the catch. We're doing a wraparound, right? So when we do 2 times 3, we're going to come back around to here, and I'll write this in a different color here. So this will be 6. And I wrote the wraparound in a different color so we can see it. Okay, now we're on our third element. So this is just all zeros, but let's recall where we start. It's just going to be at the third element, so 0 times 1 is 0, 0 times 2 is 0, wrap around in blue, 0 times 0 is 0, and then 0 times 3 is 0. Cool. And then this is the last number, so 3. So we're just going to do the same thing. Recall we're going to start at the last spot because that's where the index I position is here. So 3 times 1 is 3, and then let's go to our blue wraparound color. So 3 times 1 is 3. We wrote that. 3 times 2 is 6. 3 times 0 is 0. And finally, 3 times 3 is 9. Cool. So we've just done our sort of flip and shift multiplication operations, but what do we do when we do this? First of all, I'll stop here. Do we have any questions on so far what we're doing? Basically, we're performing a convolution, which the equation is written here on the board on my left. Yes, Rachel?
Why are we doing this?
Yes, so what we want to do is we want to combine this signal x with the filter h, as we've written here on the board, to get y. Right? So we're doing a circular convolution so we can get the combination of these signals. An example of something like this would be my voice. So here's me and my extremely loud voice, and here is the wall. The wall here is like a filter H. Basically, when my voice hits the wall and it bounces back, this is like Y right here. So this is H, this is Y. Why is this the case? It's because H, the filter, the wall, kind of warped my loud voice a little bit. It sounds a little different when you hear the echo of my voice against the wall instead of when you just hear the authentic my voice. So this is kind of the idea. This is why we want to find the convolution of x and h, because maybe sometimes it's more significant than just the wall and my voice. Sometimes it's the Apple's newest 6G technology versus maybe it's military radar out there in the ocean. I mean, there are so many uses for this sort of operation, and we need to be able to do it efficiently. So thank you for the question. And so we can continue on here. And finally, all we need to do is do the last step of the convolution operation, which is to sum everything up, which we'll do that right now. And of course, let's not forget the scaling factor. So I'm just going to write the scaling factor 1 over 4 here because there are 4 elements. And we're going to add everything up column-wise. So what's 1 plus 6 is 7, plus 6 is 13. Okay, 2 plus 2 is just 4. 4 plus 9 is 13. 3 plus 3 is 6. Cool, so now let's go to our last stage, and I'll write this last final answer in red here. So all we're going to do is apply this scaling factor by everything. So that is what I am doing now. So the third element is 13 over 4, and finally 3 over 2. Perfect. So we've gotten to our final answer. What does this represent again? This is the circularly convolved version of x and h, our input signal and our filter. And we've successfully gotten to the final answer. So in conclusion, we were able to convolve these two signals together, and we can do a plethora of things that we mentioned before regarding signals and their filters. Thank you very much.
Okay, great. Thank you, Dennis.